it says function notation. So here we've been given 3 functions, and it says, are these functions or just equations? So the first part of the lesson, I'm going to teach you guys how to determine whether something is a function or not. And a lot of times it's all about the x's. This is something you would have heard probably back in Algebra 1A, I think, was like the first time it's introduced, maybe even pre-algebra now. But down here, this is the most important part. If it is a function, all of your x values are going to be different. You should never see an x repeating itself. Okay, so if you look here, if you look at this first table, do you see any x's that repeat? Yeah, like right here and right here. Okay, so if you look at their x's and you see repeating x's, what's supposed to happen is if you see this number twice, this number over here better match. Like they would have given you the same ordered pair twice, because what they're saying is if you plug in a -2, this one says you'll get 3 as the answer. But then a couple seconds later it says, no, if you plug in a -2, you're going to get 5 as an answer. Well, that does not happen if it's a function. So this one right here, since our x value repeats and this x value has 2 different outputs, this one would not be a function. Okay, then if you look at the second table and you look down this first column, do you see any repeating x's? No, all of my x's are different. So is that one a function? Mm-hmm. This one would be considered a function, and that's because none of the x's repeat. Now, if they give you a picture, there is a certain test we use to determine whether it's a function or not, but right now I just want you guys to look. Let me just pick 2 points. Like if I picked this point here and this point here, this ordered pair would be 6, 6, and this ordered pair down here would be 6, -2. Are you allowed to have one x value have 2 different y values? No, not if it's a function. So this one would not be a function because 6 has 2 different outputs. I mean, you could have picked other places too. Like it would have happened here at the 2. I mean, obviously this would start with 2 and this would start with 2. This would start with -4 and this point would start with -4. So there's several places where you would have repeating x values. I just happened to show you guys those two because I could see like the whole numbers. And then what about down here? I don't think this point, like there is a point right here. It did not show up very well. Some of these points didn't show up well when I printed it. And even though it's not, like you guys can't even see the grid lines, but let's just say this was -1 right here. Aren't there 2 points that would start with -1? These two? And then like don't both of these start with 0s? And then both of these both start with 3s? So are you allowed to have that happen for a function? No, so this one would not be a function either. And I would just say repeating x's. And then whenever you're ready, go ahead and turn the page. Now, I just talked about how to figure out if something was a function. In order for it to be a function, none of your x's should repeat and have different y values. On the next page, they're going to talk about, okay, well, if I give you a function, is it 1 to 1? Well, if it's 1 to 1, every input produces a different output. So now they're saying that none of your y values should repeat. Okay? So none of the y's should repeat if it's 1 to 1. Bless you. So like I said, they've already told us that it's a function, so all the x's are going to be different. But now we need to take a look at the y's. So if you guys look over here where this mapping diagram is, if I were to write these as ordered pairs, I would have 1 comma C, 2 comma B, and then 3 comma C. So listen, it's a function because none of my x's repeat, but is it 1 to 1? Why not? Okay, so this right here and this right here would make this one not 1 to 1. So even though it's a function, it is a function, but it's not 1 to 1. You guys are going to be given problems today where like you're going to have to say, is it a function, yes or no? And if you say yes, then you have to tell me, is it a 1 to 1 function? So first, always check your x's and then check your y's. Okay, so then this one. We already know that this is a function, okay? So it's a function because none of our x values would repeat. But then, are any of our y values the same? So if you were to draw like these horizontal lines, are any of the y's going to fall on the same line? No. So since all of the y's are different, it would be 1 to 1. So all y's are different. And it's a function because all of our x's are different. Now for this one, is it a function? So are any of our x values the same? Well, no, none of this parabola, like we wouldn't see any x's that would be the same. So it's definitely a function. But as far as the y's go, isn't this point right here the same height as that point? And isn't, I mean, I could, wherever else I could draw it, like this point right here, I'm trying to make it even. Like those 2 points are the same height, aren't they? We know they're mirror images of each other. So is this one 1 to 1? No. So not 1 to 1. Because there are repeating y values. Yeah, they have something called a vertical line test to check your x's, and then they have something called a horizontal line test to check your y's. And I think that's coming up. Yeah, they talk about it on the next page, but right now we're just going to look at the pictures and see if we can tell. So are any of the x values here the same? Do any of the x's here match each other? Nope, so that one is a function. Do any of them have the same height? Do any of the points have the same height? They don't, do they?
No.
Okay, so this one would also be 1 to 1. Okay, now look at the one in the middle. This one right here. Okay, but look, isn't this x value the same as this one, the same as this one, the same as this one? So aren't all those x's the same? So is that one even a function?
No.
Okay, since this one's not a function, I don't even have to worry about the one-to-one thing. If it's not a function, that doesn't even matter. Okay, what about this one over here? Are any of the x's the same?
No.
Okay, so that one's a function. So since we know it's a function, then talk to me about the y's. Are any of the y's the same?
No.
Okay, so then it's one-to-one. All right, then this one here. What do you guys think about this one?
Not a function.
This one? So are any of our x's the same? Like if I were to draw a line, would any of our x's match up?
Yeah.
Where?
No.
Nowhere?
Well, the opposite, but...
Right, but I mean exactly the same. Like all these were the same x.
Oh, yeah.
But these are all different, right? So since these are all different, this one is a function. And then what? It's not one-to-one? Right, because this right here has the same height as this does. You've got this one down here has the same height as that one, right? They're the same distance away from the x-axis. So this one is not one-to-one. I think it's easier when you actually start drawing the lines, but like I said, they don't actually tell you about the vertical line test and the horizontal line test to the next page, but most of the time, if they're going to give you a picture, that's what we're going to end up using. Okay, so then this one, do any of our x's repeat on this one? Okay, so that's a function, and it's not one-to-one because, I mean, if you guys were to look sideways, you know, this would have a height of 2 and this would have a height of 2. So that would not be okay. So it's not 1-to-1. Are we okay with that? So as soon as you guys turn the page, we're going to talk about that vertical line test and the horizontal line test. Okay, so if you guys take a look, this is exactly what I was talking about. So if something is a function, it will pass the vertical line test. Okay, so this is how you test to see if something is a function or not. Function or not. So watch, we're going to do that one first. If you take a look at this circle, if I were to draw a vertical line, it should only pass through one point. Bless you. Does this only pass through one point? No, so that does not pass the vertical line test. So that one is not a function. And if it's not a function, I don't have to worry about the whole one-to-one thing either. If you look at the parabola in the middle, okay, anywhere I draw a vertical line, anywhere, it's only going to pass through one point on that parabola at a time, right? None of my x's would match. So since it passes the vertical line test, it is a function. Okay, so this one is a function. So since it is, then we need to start looking at horizontal lines. Oops, I can't even draw horizontal lines. Okay, so then what we'd want to do is we'd want to start looking this way. If it passes through more than one point horizontally, it is not one-to-one. Is that one one-to-one? No, because some of the y's match each other. So it's not one-to-one, but it is a function. And then for the last one, okay, you don't have to even use this vertical line, but anywhere, I mean, you can just draw random vertical lines. Will any of those vertical lines pass more than 1 point at a time? Okay, so that one is a function. We've got a function here, and because it is a function, then we want to start looking horizontally. So if I were to draw horizontal lines, like that horizontal line passes through 1 point, this horizontal line passes through 1 point. Will there ever be a horizontal line that passes through more than one? No, so this one is a 1-to-1. That last one passes both the vertical and the horizontal line test. All right, now we know, based on what we just saw here, all of our parabolas are functions, right? We know they're functions, but they're not going to be 1-to-1 because they're going to be mirror images of each other. Isn't this going to be a parabola? We know that's going to be a parabola because it's x squared. And all parabolas, we already know. So if you guys are ever given a quadratic, we automatically know that it is a function, but it's not 1-to-1. I don't know why I put that one there. Not 1-to-1. I didn't mean that one. Now for x cubed, you guys remember with the x cubed graph, you remember what it looks like? If the number out front's positive, remember we start low and end high? Remember that? The wavy thing. So, but this is all I know. Like, I know that my graph is going to do, I mean, it's going to do something like this, right? I mean, I don't know how many times it's going to do that. But if I know that x cubed with a positive out front is kind of that shape, is it a function? Like, are any of our x's ever going to match? Okay, so this one's definitely a function, but since we don't know exactly what the picture looks like, you know, the picture I just drew kind of looks like some of my y's are the same height, but are they all necessarily going to be? I don't know, because I don't know the picture. I don't know what the picture looks like. So right now, all I can tell is that this one is a function, but we don't have enough information to determine whether or not it's 1-to-1. So I'm just going to do this. I'm going to say 1-to-1, and I'm going to put a question mark. And I'm just going to say not enough info. We would need to have the picture there to tell whether or not it was 1-to-1. And what do all absolute value graphs look like? What shape? They look like a V, right? And since it's positive out front, we know it's going to be facing up. Okay, so tell me, is that a function? It would be a function, but not 1-to-1. Good. All right, so then when you guys turn the page, now we're going to do function notation. You guys are going to love this. It's super simple. So much easier than some of the stuff we've been doing. I promise. Okay? Now, you guys remember back in Algebra 1, you always saw, you know, equations written like y equals 3x plus 4. Okay? X was always your input and y was your output, yes? Okay. What you guys are going to start seeing is f of x, which we've seen that in here already, right? Yeah, we've seen this notation. And I even told you before that if you see this notation, this is no different than having the letter y. They mean the same thing. X is always your input, and whatever's on this side is always your output. So this is what you put in, this is what you get out. This is what you plug in, this is what you get out. So even though this looks different than the letter Y, they literally mean the same thing. And we read it as f of x. And if you read all this, it says everything I just told you. It says, we use the notation f of x when working with functions to designate our output. It really is the same thing as saying y equals. Functions are just special types of relations where each x value has only one y value. X is always your input, and then f of x is always going to be the output. Okay? So what I'm going to do is I'm going to give you guys some functions like this one here. Okay? So this one says f of x equals 2x minus 3, and they want you to find f of 1. So what did they just give you? They gave you the x value. What are we going to do with that? We're doing a plug and chug, guys. Super simple. So all you would have to do is write this. You would write this side of the function, but instead of putting the letter x, they told us to plug in. Oops, I just put the wrong symbol. Hang on, don't write that down. That should be a minus. I don't know why I put plus. It would be 2 times 1 minus 3. Sorry, that should be a minus. Now it looks like a division symbol, doesn't it? Can tell it's kind of Monday, right? I know it's Tuesday, but it's the first day back. Yes, exactly. Okay, so when you guys go to write your answer, this is how I will expect it to be written. I always want this function notation on the left side. So you're going to say f of 1 equals, and then all you guys have to do is figure out what this equals on the right side. If you can't do it in your head, do it in a calculator. 2 times 1 minus 3. I heard a couple of you say it already. -1. Okay, what are they telling me to plug in here? They're telling me to plug in the letter A. So wherever I see the letter X, I'm now plugging in a letter A. Okay, so what would I get? Can you actually... Aren't you just going to get 2a minus 3? I mean, there's nothing else that you can do to it. 2a minus 3. And then for this last one, they now want us to plug in h plus 1. So in the parentheses next to the 2, we're going to plug in h plus 1. Well, what do we have to do here? So distribute, is that what you're saying? Okay, so that would be 2h plus 2. And then we would still have the minus 3. Okay, good. So the only thing we can combine are these two numbers, right? The 2h is just going to hang out by itself, and then what's 2 minus 3? -1. So that would be our final answer. So what I need you guys to understand is if they give you the number or variable or some kind of expression, if they tell you that that's in the parentheses next to the letter f, normally this is f of x. So whatever they've given you here, that is what they want you to plug in for x. So that's why we did a plug and chug. there will come a time where instead of giving you the x, they're going to give you the output and we'll have to solve for x. Okay, so that'll require an equation. But do you guys feel comfortable with the plug and chug ones? That's fine.
I'm gonna need that.
Oh, so this was, so since the C's repeated, it was not 1-to-1. Caleb, you just let me know, okay? For everybody else, if you could turn the page, see if you could, see what you could do on the next one. So see what you're able to get on the next two. They give you a new function and they give you a number to plug in, and then they give you a second function and they give you something else to plug in. Okay.
Oh, so we're solving two different equations on the first one?
Well, no, on this one, they're just telling you to plug in a -2 where the x is. So I would do f of -2 equals. Now, if you have to square a number, what are you supposed to do? No, if you're supposed to square a number, what am I supposed to do with that number? Put it in parentheses always. Yeah. If you don't put it in parentheses on your calculator, it's going to give you a wrong answer. Okay, so we're going to take the -2, we're going to square it, and then we're going to subtract 1. So -2 squared would be what? It would be what?
-4.
It's +4 minus 1, which is, what's 4 minus 1? 3. Yeah, remember, it's just plug and chug, guys. You're just plugging in a number, and then, I mean, if it were me, I appreciate the fact that you guys try to do some of this in your head, but there's a reason I'm telling you to put this in parentheses, because when you square a negative, it turns it positive. Okay, so if you try to do it all in your head, if you guys would have accidentally said -4 minus 1, you would have gotten -5. A little bit easier just to type it in all at once. Now this one down here, they want us to plug in 3 plus h wherever we see the letter x. So there are actually 2 places that you've got to plug in the 3 plus h. I don't remember how I made this thing go away the last time. Anybody remember? Let me see what happens when I do that. Nothing. No. Go away. Go away. Yeah, I don't know. Oh, there we go. It disappeared. Here you go. Yep. Okay, so f of 3 plus h would equal, okay, we're going to have 3 plus h in parentheses because we have to square that, plus 2 times 3 plus h, and then minus 4. Now I do think this part right here, this is going to be easy for you guys. That's just distributing. But when you square an expression, what do I have to make? If you have 3 plus h and you have to multiply it by another 3 plus h, we have to do a box problem, don't we? Anytime you square an expression, you have to do like 3 plus h times 3 plus h. You have to make a box. Three times 3.
9.
9. 3 times h. 3h. And then when you go to the bottom row, it's h times 3, which again is 3h. And then what's h times h?
1h.
Squared. H squared. Yep. You can put a 1 in front if you want. Just make sure you square the h. Okay, so this part is h squared plus 6h plus 9. Is everybody good with that? The h squared, 6h, and 9? That was just the first part. Okay, then when you distribute here, what's 2 times 3? 6. And then 2 times, I know that hurt. 2 times h is 2h. And then we have a minus 4 at the end. And now all we have to do is combine like terms, and then we'll finally have our answer. So f of 3 plus h equals. Is there anything to pair up with the h squared? No. So I'm going to start with h squared. Now let's put our h terms together. 6h plus 2h is
8h.
8h. And then we've got 3 constants. 9 plus 6, which is 15, minus 4. What's 15 minus 4, people? 11. Yep, so there's our final answer. Now look, they're not telling you to solve. They're not telling, you know, they're not saying set that equal to 0 and solve. We are just plugging either numbers. They might give you the number to plug in, or they might give you a letter, or they might give you an expression. But all you guys are doing is plug and chug. Okay? Are we okay with those? All right, that's the end of the first lesson. You are going to do a practice page, and let me just explain to you what's on the practice page. The practice page on the front, you're going to have problems like this. They're going to give you functions. They're going to tell you what to plug in, and you're just going to simplify, okay? Then on the back, you're going to be given some graphs, and you're first going to tell me whether it's a function, so you'll either say yes or no, because it says function question mark, and then they want to know if it's 1 to 1, so that'll also be a yes or no question. So the back side's going to be real simple. There's not a whole lot of work on the back. And on the front, they're actually, I don't think they give you any where you're plugging in an expression. They give you numbers every single time to plug in. So those are all just going to be plug and chug. I think you guys will get done pretty quick.